At the end of the last tape, we had completed a thorough cleaning and inspection of all of the parts from the rotating element of our pump. In addition, we performed a number of precision measurements where these were appropriate. And we said that this information allowed us to select those parts which needed repair so that the repair work could be done before reassembly. And of course, we discarded some parts that would need to be with new ones before reassembly began. So what I'd like to do now is to assume that those steps have been completed. We'll assume that any parts that were in need of repair have been repaired, and we've obtained replacement parts for those that were severely damaged and could not be reused. So that means we're ready to begin reassembly of the rotating element of our pump. So let's go back out in the shop and see how that proceeds. In preparation for assembling the rotating element, the workman has set up the shaft in another set of pedestal rollers. These particular rollers are hard rubber, so that they may be placed under machine surfaces if necessary without causing damage. He then applies a spray lubricant to the shaft. This makes the parts easier to slide onto the shaft and minimizes the possibility of scratching or scarring the shaft in the course of assembly. Then he checks the manufacturer's instruction book to determine the proper sequence of parts for reassembly of the rotating element. The first part installed is a key. The key is placed in the keyway on the shaft in preparation for installing the impeller on this end. Now he is assembling the shaft from the outboard or thrust bearing end. The choice of which end to start from is arbitrary in this case, but with other pumps the rotor is assembled from one end to the other, and then the starting point is more important. Once the key has been set in place, then he and his helper obtain the impeller which goes on the outboard end of the pump and slide it onto the end of the shaft. But they can't slide the impeller into position because the pedestal rollers are in the way. It is then necessary to lift the shaft in order to allow sliding the impeller beyond the pedestal rollers. So while his helper held the opposite end down, the workman lifted the shaft using a chain fall and a sling, moved the pedestal rollers, and slid the impeller further onto the shaft. After doing this, he then placed the rollers back in position and lowers the shaft down onto them. With this done, the impeller is then slid into its final position. That is, he works it on up on the shoulder on the shaft and over the key until it is finally seated up against the sleeve, which is installed in the center of the shaft. The next component to install was the packing sleeve for the outboard end, which of course secures the impeller onto the shaft. So again, the shaft is lifted while the helper holds the opposite end down. Then the workman takes the proper sleeve and slides it over the outboard end of the shaft and works it on up into position. Now you recall that these sleeves thread onto the shaft. So after sliding it up into position, he threaded it into place. Now at this point, the sleeves receive only an initial tightening, that is, just snugged up. As we'll see, a final tightening is not done until the rotor is in the pump casing. So after snugging up the packing sleeve, he is then ready to install the next component, which in the case of this particular pump is the gland follower. You remember, these gland followers are of one-piece construction, which means they have to be slid up onto the shaft before the rotating element is installed in the casing. Two-piece followers, of course, could be left off until you were ready to install packing. But in this case, the follower is simply slid up over the packing sleeve into position and then left in that position until later. With the gland follower installed, the shaft could then be lowered again into the pedestal rollers. Now remember, these are rubber rollers, so it's not an improper procedure to lower the shaft down onto them. At this point then, after another check of the manufacturer's instruction at this book, he was ready to begin assembly of the parts related to the bearing for the outboard end of the rotating element. The first part required here was the bearing seal. Now here we see the importance of carefully tagging and labeling parts after the cleaning and inspection process, because this streamlines the operation at this point. He knows exactly which part to get and where to install it. After the bearing seal has been slid up over the bearing journal area of the shaft, the next component required was a small spacer. It's actually a gasket, which is installed between the thrust collar and the shoulder on the shaft against which the collar seats. With this set in place, the thrust collar itself could then be placed over the end of the shaft. So after removing it, rotating on the bag and double checking the tag, the workman takes the thrust collar and slides it into position, using care to be sure that it fits over the small key provided on the shaft to prevent it rotating on the shaft. Then, with the thrust collar installed, he is ready to install the washer and nut which secure the collar to the end of the shaft. Now you notice how quickly this assembly goes, because all the parts are ready, they have been cleaned, inspected, and carefully identified. So it's simply a matter of taking the proper part and placing it into position in the proper sequence. And of course the sequence is dictated by the construction. So it's important to frequently check a drawing or other information in the manufacturer's instruction book. Now, like the packing sleeves, this nut receives only an initial tightening at this time and will be finally tightened once the rotating element has been installed in the pump casing. Before installing the bearing shells, he applies spray lubricant to the thrust collar, again to avoid the possibility of bearing damage during installation. Now, the exact lubricant used will vary, of course. In this case, a spray is used, while in other cases, lubricating oil may be applied with a brush or a spray can. Now, you recall the sleeves for this outboard bearing were assembled using a hose clamp to allow precision measurement. They have been stored in that condition since then, so the first step in their installation is to remove the hose clamp which has been holding them together. Assembled. After the hose clamp has been removed, then the two shells can be placed over the bearing surfaces. Now you'll notice he exercises care to properly engage the slots in the bearing shell with the discs of the multi-disc thrust bearing. Then, after the two halves have been assembled on the shaft, he takes the hose clamp and reapplies it to the two halves of the bearing shells to hold them in location. The hose clamp will remain on them until just before the rotating assembly is lowered into the lower half of the pump casing. This then completes the assembly of one half of the rotating element, you might say, the outboard end. For this, he's ready to start on the inboard end. Now, there are a couple of key components which have not yet been installed in this end of our rotating assembly. One associated with the bearing and the other with the impeller that we've seen installed. So first, let's talk about that bearing. We saw our workman install the thrust collar, and we also saw him install the shells for this bearing, which, as you'll recall, is a combination sleeve bearing and thrust bearing. But he has not yet installed the oil rings associated with this bearing. This is because these rings would just be set in place and then could easily be knocked off the shaft again and possibly damaged. So he'll keep those in their protective plastic bag until he's ready to lower the rotating assembly into the pump casing. And of course, we'll see that step later on. I said the other part he'd not yet installed was associated with the impeller. Let's take a look at this drawing and I'll show you the part I'm referring to. That part is the stationary wearing ring. Now, this is the impeller that we've already seen installed on the shaft. But the stationary wearing ring, which goes over the rotating ring on the impeller, has not yet been installed. And that again is for the same reason, because that ring might easily be knocked off and possibly damaged. So instead of taking that chance, he's keeping that ring set aside, and he'll install it right before putting the rotating assembly in the pump casing. Well, we still have to talk about assembly of the second half, or the other half of the rotating element. But I think before we do that, what I'd like you to do is to stop the tape at this point and review what we've already discussed with your instructor. Well, in the last segment, we saw the assembly of basically half of the rotating element from our pump. The workman is back out in the shop preparing to begin the assembly of the other end of the rotor. So let's rejoin him and see how he's doing. A check of the manufacturer's instruction book shows that the next component to be installed, or I should say the first component to be installed from this end, is a stationary wearing ring associated with the impeller which is already on the shaft. As with the other parts that we've already seen, it's necessary to lift the shaft free of the pedestal rollers in order to slide the stationary wearing ring over it. So the shaft is lifted slightly to allow passing the wearing ring past the pedestal rollers, and then is again lowered into position. Now it's important during these operations to always maintain proper support for the shaft, and it should be sitting in rollers or some similar form of support whenever possible, as opposed to leaving it hang from a lifting device, which is a somewhat unsafe practice and may result in shaft damage. So after lowering the shaft back onto the rollers, the stationary wearing ring was then set in place, which means it was slipped over the rotating wearing ring on this side of the impeller. Now once the rotating element is in the pump, this stationary ring, of course, is supported by the pump casing itself. So at this point it's just riding on that rotating ring. Now the next component to be installed is the guide ring, which you recall is a large guiding assembly which goes in between the two impellers on this pump. Now if you remember my description from before, this particular part does not turn with the rotating element. Instead, when it's installed in the pump, the guide ring is held stationary in the pump case and the rotating element turns inside it. Now the first step in its installation is to place it over the end of the shaft. Then, as before, the shaft must be lifted to allow passing this guide ring, or channel ring as it may be called, beyond the pedestal rollers. So the shaft is lifted, the pedestal rollers moved out of the way. The channel ring or guide ring is slipped up onto the shaft, using care not to set it directly on the threads for the packing sleeve, and then the shaft is again lowered into the pedestal rollers. With the shaft in the pedestal rollers, the sling is then slipped aside to allow placing the guide ring into its final position, which for the time being is on top of the sleeve in the center of the shaft, because this component, like the stationary wearing rings, is simply riding on the rotating assembly for the time being, but is supported by the pump casing when the rotating element is assembled into the casing. At this point, the workman again checks the manufacturer's instruction book to confirm that the next component to install onto the shaft is the other impeller. However, before the impeller itself is set in position, as with the previous impeller, the key is first placed in the keyway on the shaft. Now it's important when installing a key to be certain that it fits properly in the keyway and that it is seated properly in the keyway. A worn key or keyway will result in a wobbling impeller. So with the key installed, the impeller itself can then be placed on the shaft. And as before, lifting and carrying one of these impellers requires two men. In fact, on some very large pumps, it may even require lifting devices such as chain falls or come-alongs to safely move an impeller. In this case, the workman and his helper take the impeller and slide it over the end of the shaft. As with several other parts that we've seen, this impeller cannot be slid into its final position because the pedestal rollers are in the way. So the workman lifts the shaft with his chain fall to allow sliding the impeller past the pedestal rollers. With the shaft lifted, the pedestal rollers can be moved out of the way, and then the impeller is slid further onto the shaft. After doing this, the rollers are set back in position, and of course the shaft is lowered back into them. This then allows the workman to take the sling and pass it over to the outside of the impeller, and then of course place the impeller in its final location. This is done just as we saw before, by sliding it up onto its shoulder and over its key, taking care to be sure that the key is properly engaged in the slot in the impeller hub. Then the impeller can be pushed into its final location, which we said in this pump is determined by the sleeve installed in the center of the shaft. Now you notice that the workman then confirms that the guide ring or channel ring is still free to move. As before, the next component following the impeller is the packing sleeve for this end, which of course secures the impeller onto the shaft. So the workman lifts the shaft slightly free of the pedestal rollers and then obtains the packing sleeve. And this sleeve is installed in exactly the same manner as the one we've already seen. It is passed over the end of the shaft and slid up into position. Then, after lowering the shaft onto the pedestal rollers, the sleeve can be threaded onto the shaft. Now you'll notice that this sleeve has a left-handed thread as compared to the right-handed thread on the other sleeve. This is so that the sleeves do not become unscrewed while the pump is in operation, and is a very common design feature of this type of pump. As with the other sleeve that we've already seen, this sleeve receives only a preliminary tightening at this point, because the final tightening is done after the rotating element has been installed in the pump casing. Now with the sleeve placed on the rotating element, places it. The next part to install, as it was on the other side, is the gland follower. This again required lifting the shaft above the pedestal rollers to allow the follower to be slid in place. So the workman lifts the shaft and then removes the gland follower from its bag and places it in the proper position on the packing sleeve. Now with the gland follower set in place, he is then ready to install the various components related to the inboard bearing. Now this particular bearing makes use of two bearing seals. This is because the shaft passes all the way through the bearing, as opposed to only one side of the bearing, as with the outboard side. So this seal goes on the inner side, if you will, of the inboard sleeve bearing, while the second seal goes on the outer side of the same bearing. Now with the part slid onto the shaft, the workman then again lowers the shaft into the pedestal rollers. Now the end of the shaft that he is working with at this time is the inboard or coupling end. So the next component which had to be installed onto the shaft was the hub for the coupling, which couples the pump shaft to the motor shaft. However, before placing the coupling on the shaft, a key had to be placed in the keyway. With the key properly set in place, of course, the coupling hub would follow. Well, with that, we've completed the assembly of the rotating element of our pump. And of course, the next step in the overall reassembly process is to take that rotating assembly and reinstall it back into pump casing. But as usual, before we start a new subject area, I think what I'd like you to do is to stop the tape now and review rotor assembly with your instructor. Well, in the last two segments of the program, we've been following the reassembly steps for the rotating element of our pump. And at the conclusion of the last segment, we had the rotating element fully assembled. Well, that means the next thing we need to talk about is installation of that rotating element back in the pump casing. Now, while we took our break, our workman is kept busy. He placed two more components on the rotating element. So before we go any further, let me point those out to you. Those two components were two stationary wearing rings, one on the outside of this impeller and the one on the outside of this impeller. Now, if you remember, I said he was delaying placing these wearing rings in position because of a concern that they might later fall off and be damaged. So he waited until he was ready to take the rotating element back down to the pump site before placing those wearing rings in position. So he has done that, and he has lifted the rotating element and placed it in the cart that he used to transport it before. And he's on his way down to the pump casing. So let's catch up with him and see what he does next. After completing the installation of the coupling hub and also setting in place the remaining stationary wearing rings, the workman and his helper then proceeded, as we see here, to take the rotating element down to the pump location for installation in the casing. Now they did this using the same fabricated dolly that they used when they removed it. And it's important to recall that you must use extreme care when transporting equipment such as this to avoid damage to particularly vulnerable parts. With the rotating element transported to the pump location, the workman then rigs up using lifting devices in order to lift the rotating element and place it in the pump casing. Now the precautions that need to be followed in this operation are the same ones that we discussed earlier when the rotating element was removed. Only approved lifting equipment and approved rigging procedures should be used. So following these procedures, our workman lifts the rotating element and swings it over the pump casing in preparation for lowering it into the casing. Now it's a good practice, as we see here, to set the rotor down on blocks set across the pump casing before actually lowering it the final step into the casing. So what you see here is blocks being set across the pump casing in two locations to support the rotor, and then the workman lowers the rotor down onto the blocks. This allows a final adjustment of the various parts on the rotating element and final adjustment of the rigging before the rotor is finally lowered into the casing. This is the final positioning of such things as bearing oil seals, oil slinger rings, the packing gland followers, and the rigging itself, so that the rotor will properly fit into the casing without interference of parts or without interference of the lifting slings being used. In addition, this step allows for the installation of any parts not yet placed on the rotating element. For example, in our case, the workman kept the slinger rings for the outboard bearing in their protective bag until this point, rather than risk damage to them. So the final step before lowering the rotating element into the pump casing was to install these two oil rings. Once these steps have been completed, the rotating element is again lifted to allow removal of the blocks, and then finally lowered down into the pump casing. Now this step is not near as easy as it sounds. In fact, frequently several tries will be necessary. What's required as the rotating element is lowered is to carefully position each movable component on that rotor in order to be sure it's in the proper location and is fitting properly into the casing as the rotor is lowered down. And what we're talking about here are such things as bearing seals, oil rings, packing gland followers, and especially the stationary wearing rings, which you see being positioned here. In most cases, these rings will have small dogs on them, which must fit properly into slots in the casing. This prevents the rings from turning when the pump is assembled. So it's necessary to carefully position each wearing ring as the rotating element is slowly lowered into the pump in order to be sure that it properly engages the slots in the lower half of the pump casing. And of course, the bearing components need to be carefully positioned on both ends. In our example, the helper is positioning these parts on the inboard bearing, which you recall has two bearing oil seals and an oil slinger ring. But in any event, be certain to exercise care and be sure that all parts are properly positioned as the rotating element is lowered. In some cases, this may require several trials before the parts fit properly, but care must be exercised or damage to the pump components can result. After he has lowered the rotating element into the lower half of the pump casing, the workman then removes the hose clamp which was holding the two halves of the outboard bearing shells in place, because now, of course, they are being held by the bearing support itself. And then finally, he lowers the lifting apparatus which has been used to position the rotor, disconnects it, and removes it. So while he disconnects his rigging, and before we start a new subject area, I'd like you to stop the tape at this point, take a short break, and review rotor installation procedures with your instructor. Do you remember in the last tape we discussed a process by which we determined oil clearance for the sleeve bearings on our pump? If you recall, this involved measuring the diameter of the bearing journal on the shaft and also measuring the inside diameter of the assembled bearing shells. And then we subtracted one dimension from the other in order to determine the clearance between them. Well, there's another method for determining oil clearance, which is frequently used during assembly of a pump and is going to be used during the assembly of our pump. And this method makes use of a material called plastigauge. And what this is a very fine strand of plastic-like material which is placed in the bearing. Then the bearing is assembled, essentially squashing that material, if you will, squeezing it down. Then the bearing is disassembled again, the plastigauge material is removed, and its dimensions can be measured using a micrometer. And of course, again, this indicates the oil clearance in the bearing. Well, our workman is preparing to do this procedure on the inboard sleeve bearing of the pump that he's been working on. So let's go out and see how this is done. As with all the other precision measurements we've seen, the first step the workman performs is to check the specified value for bearing oil clearance in the manufacturer's instruction book and transfer this information to the data sheet, which will be kept as part of the records of this pump overhaul. I might mention he also checks the torque specifications for the nuts which secure the bearing cover. Now, the rotating element was set in the pump without the shells being installed on the inboard sleeve bearing. So the first thing the workman does is to install the lower shell of the sleeve bearing. So he applies oil to the bearing journal on the shaft and also to the bearing surface itself, and then takes the lower shell and rotates it in under the shaft, using care to be sure that he properly aligns it in the bearing housing, and also using care to be sure that the oil slinger ring is in the proper position. After making these checks, then the bearing shell is simply turned in under the shaft in order to get it in the proper position in the bearing support. After doing this, he then cleans up the excess oil which is on the bearing housing. And the next step that he performs is to apply some grease to the shaft. Now, this grease will be used to hold the plastigauge material in position where he needs it. So he applies little dabs, if you will, of grease at various locations on the shaft. And as we're going to see in just a moment, a piece of plastigauge will be placed in each location where the grease was applied. In appearance, the plastigauge resembles a very, very thin wire. It's available in different sizes depending upon the size of the measurement to be taken. The way it's applied is to break it by hand into pieces of the proper length. And then the pieces of plastigauge are embedded in the little spots of grease that were already applied to the bearing journal. And the workman continues to repeat these steps until one piece of plastigauge has been placed in each location where he applied grease. After all of the plastigauge has been set in position, the workman is then ready to install the bearing cover, which of course contains the upper half of the bearing shells. So he lowers the cover into position, using care not to dislodge the plastigauge material. And from here, the assembly of the bearing is exactly the same as if this was the final assembly. The cover is set in place. The two alignment pins that are used on this particular bearing are extended to be sure that it's aligned properly. And then the nuts, which attach the bearing cover to the lower half of the bearing housing, are set in place and threaded on. Now, it's important to remember that if there's a gasket, a spacer, or anything like that required in the assembly of the bearing, it must be put in place during this plastigauge process, because any gaskets or spacers will affect bearing clearance. And of course, that's what we're trying to measure in this case. So the workman continues until all four nuts are threaded onto the studs which hold the two halves of the bearing together. Then, using a torque wrench, the workman tightens the four nuts using a crisscross pattern up to the torque value that was specified in the manufacturer's instruction book. As I said, this assembly is conducted just exactly the same as if the bearing was being assembled for the final step. So the nuts are progressively tightened in the proper crisscross pattern up to the specified torque value. And now comes the difference between this and a normal bearing assembly, because once the nuts have been tightened down, the bearing is fully assembled, he then immediately removes them again. Now the point here, of course, is he is now going to remove the plastic gauge material from the bearing and use that as a determination of bearing oil clearance. So to accomplish this, the 4 nuts are loosened and removed from the studs which hold the 2 bearing halves together. Then, with the nuts removed, the bearing cover can be carefully lifted off and set aside. This then exposes the plastic gauge, which has now been compressed so that its size is indicative of the bearing oil clearance. So what the workman does next is to remove each piece of plastic gauge one at a time and measure its thickness now that it's been compressed. So he makes use of an outside micrometer. And as I said, he removes each piece of plastic gauge one at a time from the grease that was holding it in place on the bearing journal. Then, after he has removed the plastic gauge, he carefully measures its compressed thickness using the outside micrometer. And then, once this dimension has been accurately determined, he notes it down on the log sheet that he uses for his precision measurements. Now, I should alert you to something that may happen in the course of plastic gauge work. You may find that some of the plastic gauge will adhere to the bearing cover as opposed to the bearing journal. There's nothing wrong if this happens. It's simply a matter of noticing that it has happened and then removing it from the bearing cover and measuring it as before. Now, you may be wondering why our workman only applied plastic gauge to the top of the shaft when he was performing these measurements, instead of putting some under the shaft and some over the shaft. Because after all, what he's determining is oil clearance, which we said is the clearance all the way around the shaft when the shaft is centered in the bearing. Well, at times we will do this. That is, we will use plastic gauge all the way around the shaft. But as you can imagine, this involves some doing, because it means that rotating element is going to have to be lifted out and in a number of times in order to perform the plastic gauge measurement. Well, instead, what our workman did, and it's a perfectly acceptable procedure, was to place the rotating element in the casing where it's resting on the lower shell of the bearing, and then simply use plastic gauge on top of the shaft. Well, this means all of the clearance is on top of the shaft, because in this condition the shaft is not centered in the bearing. So what he did after taking these measurements and after determining the clearance between the shaft and the top bearing shell was then to divide that clearance by 2, because with the shaft centered, half of that clearance would exist on either side of the shaft. So he took all the dimensions that he measured, divided by 2, and that number then became the actual measured oil clearance. Well, once this clearance has been determined, compared to specifications, and if we assume that the clearance is found to meet the specifications, then he is ready to assemble the bearings for the final time. But I think before we get into those procedures, this is again a good time to stop, take a short break, and let you review plastic gauge procedures with your instructor. In the last segment, we discussed plastic gauge procedures as applied to determining oil clearance on bearings. Our workman performed these plastic gauge procedures on the inboard sleeve bearing of the pump that we've been working on. He found the oil clearance to meet specifications, and he's now getting ready to assemble that bearing for the last time. So let's catch up with him and see how he's doing. The final assembly of the inboard bearing is essentially a repeat of the procedures we've already seen. After completing his plastic gauge work, the workman wipes off the excess grease that was on the pump shaft, then applies oil to the shaft so that the bearing will be well lubricated when it's assembled and will have oil in it when the pump is first started. After applying a thorough coating of oil to the bearing journal on the shaft, he then picks up the bearing cover, which of course contains the top bearing shell, and lowers it into position. Now, you recall this particular bearing does not make use of spacers or gaskets between the 2 bearing halves. Then, using a small ball-peen hammer, he extends the 2 alignment pins into the lower half of the bearing support to be sure that the 2 bearing halves are properly aligned, and then takes the 4 nuts which attaches the 2 bearing halves together and carefully threads them onto each of the studs. Then, with the nuts threaded onto the studs, he takes his torque wrench and in a progressive crisscross sequence tightens the nuts up to the specified torque value which he determined earlier in the manufacturer's instruction book. Now, this then completes the assembly of one bearing of our pump, the inboard bearing. We've seen the steps involved in a plastic gauge check of bearing oil clearance. After that clearance was found to meet the specifications in the manufacturer's instruction book, the bearing has now been finally assembled for the last time in the pump overhaul sequence. Well, that completes the inboard bearing. But what about the outboard bearing on our pump? Well, if you remember our earlier discussions, the outboard bearing on this particular pump is an entirely different design. It's a combination sleeve bearing and thrust bearing. And the two shells on this bearing have their dividing line or split aligned vertically instead of horizontally when the bearing is installed in the pump. So the shells had to be placed on the shaft before the rotating element was lowered into the pump casing. For this reason, it was not practical to plastic gauge this particular bearing. Instead, the measurements that we discussed in the last tape were performed in order to determine that the oil clearance was proper. And now what we're seeing is the final assembly of the bearing. Now, as you probably noticed, this bearing uses a gasket between the two halves of the bearing cover. So the gaskets were set in place on each side. Then the bearing cover was set in place exactly like it was for the inboard bearing. It was set over the studs and the alignment pins were extended. And the workman is now threading the nuts onto the studs which hold the bearing cover in place. And of course, once all of the nuts have been threaded onto the studs, they need to be torqued. Now, since this bearing is a different design than the inboard bearing, before torquing the nuts which hold the two bearing covers in place, he again checks the manufacturer's instruction book to determine the torque specifications for these studs. After determining the specified value, he then takes his torque wrench and, as with the other bearing, tightens the nuts in a sequential manner and in a crisscross pattern until 4 nuts have been drawn up to the torque specifications which he found in the manufacturer's book. With both bearings assembled, the workman then prepares to make another important measurement on the pump. Now, you may hear this measurement referred to in several ways. Some people just call it checking the thrust. Technically, it's a measurement of the axial movement of the shaft. As we're going to see, what the workman checks is how far the shaft is allowed to move in each direction in the thrust bearing. So what he's doing now is rigging up a dial indicator such that it will read axial movement right at the outboard end of the pump shaft. So he sets the dial indicator in position and zeroes it. Then, taking a bar, he pries the shaft, avoiding machine surfaces, of course, until it is moved as far as it will go in one direction. He then checks the reading on his dial indicator and, again using the bar, now pries the shaft as far as it will move in the opposite direction. Doing this, of course, then causes the dial indicator to read the axial movement of the shaft, or the amount that the shaft is allowed to move in the thrust bearing. This axial movement then is noted and compared to specified values to determine the condition of the thrust bearing and also to determine if any repositioning of the shaft is required. If it is, this would be accomplished by shimming the thrust bearing. After completing these notations and finding that the measurements met the specifications in the manufacturer's instruction book, the workman then removes his dial indicator from the pump. Now, there's another important check which should be made at this point in the assembly procedure. Let's review where we are. The rotating element has been placed in the pump casing, and the bearings have now been fully assembled, with the exception of the bearing caps, which we see the workman setting in place right now. But that other further check I'm referring to is a test rotation of the pump shaft. Now, very quickly, the next assembly procedure is going to be to cover the rotating element with the casing. But before this is done, the rotor should be turned by hand to verify it turns freely and there's no interference. However, before we talk about installing the top half of the pump casing, there's another couple of items that we don't want to forget. Let's back up and talk about the assembly of the rotating element. Now, if you remember, when we assembled the rotating element, there were two items that still needed a final tightening. One was the nut, which attaches the thrust collar to the end of the shaft, and the other was the packing sleeves. And we said we were going to complete a final tightening of both these items once the rotating element was installed in the casing. Well, let's talk about the packing sleeves. Here's one packing sleeve, and here's the other. Now, we hold off on a final tightening of these sleeves because they're the things that secure the two impellers onto the shaft. And if necessary, we can adjust the position of the packing sleeves to adjust the position of the impellers on the shaft. After centering the thrust bearing in its shells by positioning the shaft and referring to a dial indicator, as we've already seen, the impellers should each be centered in their appropriate volutes, and this can be easily verified by measuring the distance between the volute walls and the impellers, as we see being done here. Now, in our particular pump, it would be difficult to have an impeller out of position on the shaft, because their positions are established by a sleeve that is shrunk onto the center of the shaft. However, it should be checked with any pump, and with some pumps it's very easy to get an impeller out of position. So after performing this check, the workman then tightens one packing sleeve using a spanner wrench and a hammer. After this sleeve has been tightened, he again checks the measurements to verify that the impellers are still centered in their volutes. That is, to confirm that tightening the sleeve has not changed the position of either impeller. After performing this second measurement check, of course, he will then tighten the second packing sleeve. So after checking the measurements and finding them appropriate, he then takes his spanner wrench and his hammer and tightens the remaining packing sleeve. Now, after completing a final tightening of both packing sleeves, it's a good idea to come back and one more time double check the position of the impellers in their volutes. As before, this is done simply by taking a ruler and checking the distance between the volute wall and each side of each impeller. After tightening both packing sleeves and double checking that the impellers are still centered in their volutes, the workman then completes a final tightening of the nut which holds the thrust collar onto the end of the shaft. So, making use of a striking wrench and a hammer, he completes tightening this nut, and then he will be ready to install the top half of the pump casing. So with that then, we have completed all the steps necessary up to the point where we're now ready to talk about picking up the top half of the casing and placing that on our pump. But as usual, before we start a new subject area, I think it's again time to stop and review. So what I've done is I've started the casing assembly on the next tape of this program. But for now, I'd like you to stop the tape and review what we've been discussing with your instructor.